Okay, cool. Yeah, so if you guys don't know, KiCAD, it's a EDA, electronic design application or something like that. And basically allows you to make schematics for electrical things and PCBs. The schematics are fun. PCBs are more fun. I don't want to blabber on, so we'll just kind of get into it. So open up KiCAD if you haven't already, and you want to create a new project. Also stop me, preferably at the start of this if something isn't working, so you'll get like left behind.
Yeah, well, my icons are just way too big. That's not good. Try that.
Yeah. Okay. Yeah, everybody's with me there. Right, and my interface will look a little bit different than yours, probably because I think on Windows it's white.
Default white, yeah.
Yeah, actually, I wonder.
It's automatic.
It's what, sorry?
Oh, no, sorry. I tried to turn mine to dark mode.
Oh,
You just said automatic.
don't think there is a dark mode on Windows.
Oh, you only talked about dark mode so far?
Yeah,
Awesome.
most important part. Oh, okay. Thank you, Blaine. I have a mouse now, so oh, Blaine. Does it not work?
Scott was just using it.
Did you, oh, you grabbed the wrong dongle, I think. There was two in that computer.
I'll go back. I didn't.
Okay, thank you. Oh, here, take this one back. Okay, track that it is. We're off to a great start. Okay, first things first, open up the schematic editor. So you'll be greeted with a nice blank page here. So if you've ever seen nice electrical documentation online, it's because of one of these programs.
Wait, sorry. What did you click?
Schematic editor.
Thank you.
Yeah. Thank you for stopping me, because that would have been shitty if you got lost on that first step.
Make a new project first.
Yes, you do. Yeah. Okay, and inside this window here, this is where you make the schematic for things. This isn't the actual layout of your PCB, it's just how things connect together on the PCB. So sort of some basic controls. The first thing you're probably going to do is add a component, and so you just hit A, and there we go, hit A, and it will load up every single component that KiCAD has installed by default, which is like a million of them. So it might take a minute the first time you do it. And if you press A and nothing happens, press it again and like click or something, but you should see this window pop up. And
I'm gonna go start like that.
okay, I'll just keep going because I know you know how to use KiCAD already. So then inside this window, this is where you choose symbols. So like you can type resistor, and you can see that there are a million different kinds of resistor. There's like US variant, whatever, small. I'll just place down a normal resistor, double click that, and you can see now I am placing a resistor.
Does the team have a preference of the US or European style of resistor?
European. I like the look of it a lot more. The resistors, not springs. So, so once you have the component, it's easy to move it around. You can press R to, I don't know why this is not working on that. There we go. You can press R to rotate. So pretty intuitive. And then just click wherever you want, and that will place it down. And you can see you can click again. Maybe we want to add another resistor. Boom, just like that. So now to connect them together, we can press W, and W is for wire. So easy to remember. And the way the wiring works is like, it's a little bit confusing at first, but basically if you move it around and click, it like locks the last corner of the wire. So you can wire your two resistors together. And basically what you're defining here is called a net list. And it's a list of all the components and how they're connected together. So each component, like these resistors, will have like inputs and outputs, and the net list defines which inputs are connected to which outputs and that sort of thing. So that's all well and good. So to start things off, I took the liberty of Google searching simple electrical schematic, and I sent myself a picture of it. So I will send this in the Discord right now.
Oh.
And this is what we are going to create today. So everybody open up Discord and have a look at this beautiful amplifier circuit. And that, yeah, we're basically going to make this and then make a PCB for it.
A bipolar junction transistor.
Yeah, so
And three port.
so I guess I'll just like alt tab back and forth between these. Oops.
This one should have worked, but I brought the 3 others in the wrong ones. You gotta try them because
I think it is this one.
that's the one you sent me back with, though. It's number 2, and that mouse is number 2.
Oh, what the? Maybe it's right.
So
Oh, this would probably work with my mouse. That would be sweet if this.
All right, this is regular bipolar NPN bipolar junction transistor.
Yeah, we'll get there.
2 and 39 of course.
Okay, wow, none of these might work.
39 and 4.
Yeah.
is the mouse on?
Got no on or off, just the pass switch. Doesn't say what it is.
Okay.
Here's oh no, it's the mouse dead.
Oh, man. Okay, we're going without a mouse then. Yeah, exactly. Okay, so hopefully you guys are having a grand old time building this circuit. So we can start. Also, if anybody is running into any issues, please bring it up. Some other helpful things. You can press Control D on a component and that will duplicate it. So when you're laying out your resistors, that can be very helpful.
Oh, geez. Thank you. That helps me so much.
Just in case JJ hasn't gone over it, and for anyone who's curious, what JJ is currently placing down are, I believe, the European style of resistor, where in the diagram is the American style. So they are both resistors, they're equivalent, one is just one dimension, the other is another.
Okay. So I'm just placing them in roughly the same pattern that they've got here. And then go and add another component. So we'll need a capacitor. Oh, and actually another thing to note. So if you have a look at what I'm doing right now, you'll notice that when I select things, if I select top left to bottom right, the selection box is yellow. And if I select bottom right to top left, it's blue. So the way the selection works in this is blue is anything that is touching the box at all is selected, and yellow is anything that is entirely inside the box is selected. So like if I go like this, then notice how it only selects those 2 components, even though the other resistor is halfway in. But if I go the other way, then it selects it fully. So that's very helpful if you've got like a bunch of components you're trying to move around without moving other components at the same time. Oh, and another thing is if you just hover over a component, you can press M and that will allow you to move it. You don't even need to click it. So that saves you a little bit of time. Rather than clicking a component, like dragging it, you just press M while hovering over it.
Oh,
And that lets you move it. You don't need to click it either. You can just have the mouse over it. So very helpful. Yeah, and as Mike mentioned, that funny looking component with the arrow on it in the center of the schematic, that's a NPN VJT, I believe. So when you're looking for one, you can just, there we go. And then I'm going to work on wiring these guys together quickly.
Yeah.
And if you're wondering how to place a ground, it's also considered a symbol. So you can just press A.
I want to slice in this case.
So if you search in the symbols for like connector, it gives male and female.
Whatever you want.
In the amplifier circuit, like explicitly one or the other.
I don't think it says, unless there's like some kind of convention that I don't know about. I don't know if you can tell based on the schematic. So just pick whatever you want. Yeah.
Based on the schematic, VCC is coming from the connector. So typically you would have this one. The source is typically in-house, you know, this will show the source.
Okay, that's good to know. Yeah, did you look up NPN EJT?
Yeah, maybe I just have to sit down here.
Oh, it's also called transistor VAT or BJT.
Any alternative will be able to look at it. Well, the only ones that are.
If you type in 2N2219, it'll come up.
Okay, that's great. Thank
Sweet.
the NPN wasn't working.
Ah, okay. Yeah, it could be a quirk of like Linux versus Windows, possibly. Okay.
I even see like the ground.
Yeah, so that's also a symbol. So you just press the A. And then G and D. Just like that.
Okay, I just
Yeah.
ground and.
Yeah, the other shortcut is if you just hit P, it'll bring up only power symbols.
Oh, I did not know that. That's helpful. Thank you. Yeah, slowly making my way through this. P. Oh yeah, nice. Holy cow, they have a lot of a lot of power symbols.
That's what I use in the schematic. There you go.
Oh, and another thing is that just like by convention, generally ground points down and power points up. So if you look in the schematic, you can see on the connector there, we got VCC pointing up because that's your voltage in, and then ground is always generally pointing down. That's just like a convention thing. It doesn't actually matter in terms of laying out the PCB.
Usually have highest voltage at the top of the page, lowest voltage at the bottom. Give a negative voltage below ground, and then signal will be from left to right.
Right.
But again, that's a convention. It can be broken depending on what you're doing. It's going crazy if it's not readable.
Okay, so how's everybody doing so far?
So what are they together?
Cool.
Like on the phone for some.
So one thing that we're going to want to do on this connector is you'll notice in the schematic that it's not like physically connected to anything. But you still want the schematic to know that the in is connected to the in. And you do that with labels. So if you look on the right hand side of the screen, there's a few different options here. So we're going to add a net label. And that will basically, it's sort of like labeling the wire itself, and anywhere a wire shares that label, they're connected together. So I'll make a label called in. And then I can just place that here. If you look on the right, you'll notice that there's a net label and a global label. The difference between those two is that if you have a second sheet embedded inside the sheet, they're called hierarchical sheets. Where basically if you have, say, like a repeated bit of circuitry and you don't want to copy and paste all the same components over and over again, you can make a hierarchical sheet that contains just that circuit and then have copies of that sheet. A global label will be accessible from any hierarchical sheet.
There a better way to align stuff?
Yeah, there's a few tricks for alignment. What I like to do is I set the grid size to be enormous. So if you go into, where is it? You, grid properties in view. Then you can set the grid size to be really big. So if you say set it to be, this is the kind of thing that you do earlier on, but say I set the grid to be like 25 millimeters by 25 millimeters. Then, oh, actually, I think user defined grid. And then I switch to my user grid. You can see that my cursor is like super blocky now. It won't only let me place things on certain locations. So if you use a really coarse grid, it makes it easy to line things up. I don't really recommend that right now. Not at this point. We're a little too far in for that, but that is an option. Oh, there is, but I don't remember what it is. It might be like right click or something, and it like releases the last corner, or Control Z possibly. But see. Sorry, this is it. Yes, kind of.
Underscore one, /4.
Basically, it'll just be on the actual PCB and with 4 holes, so you can solder whatever packet you want on there. So you get
Only kind of it.
yeah, you get to pick the footprint
Yeah.
afterwards, but that's
Yeah.
usually what you use.
I think it's to just give you some options of what you want your connectors to look like on the schematic. Because like this type of connector probably generally has a certain type of look on a PCB. But yeah, if you look up like, you can see like this one is obviously some kind of RJ connector like you would see on an Ethernet port, right? So if you're working on like a router PCB or something, then you would use those, even though it's all just wires at the end of the day. So how's everybody doing? I think my PCB is, or my schematic is mostly done here. How's everybody else doing? Yeah, no?
Yeah, it's gotta go.
All right. Oh, thank you. Unfortunately, it didn't work.
Yeah,
So it would be, see you later.
where it might be see at the collar.
Yeah,
Okay.
the other thing you can do is those like in and out labels, you can change them to be right aligned, so they're over the wire.
Oh, yes. Okay, so
Like I think if you just like right click on them,
if you just rotate them,
oh, that's it.
How do you terminate? I mean, where?
double click.
Oh.
Yeah. How are the Zoom people doing? I can't see the chat. Yes, that label.
Where do we find?
On the right side, or you can press L. So it's the A with the line under it. If you look at my screen.
You see the right now.
Yeah.
Hold on.
You can read my Zoom chat, man.
All right.
Oh, I think we should not hear mine.
Yeah,
Thank you.
it was off and enable it, so.
Okay, how's everybody doing?
Done.
Are we all super close? Okay. wait a couple more minutes. It's looking pretty good.
All right, this is biblically simple. Wow. Okay.
That's good.
I'm talking simple compared to what I was actually doing for the other stuff.
I'm glad it's simple though, because I didn't want to do something stupid for the first first skill dev. Do some weird obscure component that isn't in KiCAD for some reason.
Oh, like at least you're not having me go build one of those sensor boards. and-
Yeah, that is a pain.
How do you automatically assign labels again?
Which kind of label?
So, I did 299 last semester.
Yeah.
Do a whole ton of KiCAD, but I remember there was a way where you just.
Yeah. We're gonna get to that next. Yep. I just want to make sure everybody's like good up to this point. Good to go?
If my wires are all like kitties, they're an easy way to.
Nope.
They
Just
don't
keep
get
at
the
it.
kitties to-
JJ.
Yeah.
I think I missed it. How do you connect that thing inside to the rest of the circuit?
This,
Yeah.
so these labels, this in is connected to this in.
Oh,
That's just the way labels work.
okay, and it's just a regular label.
Yeah, so you add a net label, they're called. It's this guy, press L.
So, yeah, and then the same
All-
name, would just be like.
Yeah.
If you have like other things and you label it.
Yeah, they'll all be connected together. And you'll see why that's important when you lay out the PCB, because you click on things and it highlights what it is connected. Yeah. So, okay,
Best practice is to put one of those on every single net. So you're never looking at your PCB and seeing just like net C4, 5, or whatever. What's a net? Basically any connection between two components.
Oh, okay.
So like, we have wires between our resistors and the transistor. But the in label is the same thing, it's just you don't have to have a wire on your page.
Oh, okay.
and so it gets really handy when you have a microcontroller with like 40 pins on it. That would mean like 40 wires snaking all over the place and it's a mess. But then you can put labels on things. Makes it a little bit easier to read.
So at what point would you like make one of these connector things versus like just labeling this?
Kind of like, in my opinion, it depends on the complexity of what you're doing. If it's starting to get hard to understand because you have so many wires overlapping that, like for something like this, it's fine. But I think it was a good use case on the connector because rather than running a wire in the whole way around, it just makes more sense because now you're looking at it, you're like, oh, that's the input of the amplifier circuit because it's called
the
in.
junction of the whole.
Yeah, but again, it's kind of like, I don't know if you have any.
No, I agree, it's up to your discretion.
Yeah.
You want to make your schematic readable. So whatever makes it more readable, whether it's compared.
All right, okay, so we'll move on to the next stage here, which is we have to give our components some values. So if you press E, which stands for edit, on top of the component, you can see that the value field is currently just an R. And we want to change that to reflect the schematic. So this resistor is 200. So I'm going to type 200. And this doesn't actually do anything other than make the schematic readable. It's not like KiCAD in the background is interpreting, oh, this resistor has to be 200 ohms. It's just for us reading the schematic to know that it's 200 ohms. We'll assign that it's 200 later. So it's 22. Okay. Upper lowercase is more correct. 2.2.
And one convention as well that's used quite a bit is instead of 2.2K, you typically write 2K2. Or
Oh,
say
interesting.
it's 2.2 nanofarad, it'd be 2N2.
Okay, I hadn't heard of that. What's the reasoning for that?
Decimals are hard to write.
Ah,
Print out
okay,
circuit, the dot is just tiny.
yes, that makes sense. Okay, cool,
Yeah, it's also done for like 3.3 volts, 3v3.
Yeah.
right. Okay. Okay, how's everybody doing on their labeling? Are we almost there?
Okay.
Doing Arturo? All done?
Yes.
Nice, Wayne?
Yeah, I'm all right.
Okay, cool, good, good. Okay, Zoom chat hasn't said anything, so I'm gonna assume that they're all good. So,
I'm sorry, quick question. Were you saying something earlier about these are just labels and they don't actually apply to?
yeah, that was something I was a bit confused about, because it was like, how does KiCAD know how to interpret like 100 NF as a 100 nanofarad capacitor? It doesn't. That's just the name that you see on the schematic.
Okay.
Basically you pick a footprint. And that's like the physical shape of the component on the PCB itself. And then when you go and buy components, you go and refer to this, and you're like, this component has to have this shape and be that value, and then it fits on this board.
Oh, so you do it that way. So
Yeah,
you don't buy the component, then choose the footprint, choose the footprint first and then.
Well, you probably make sure you can get it.
Yeah.
At that point, before you put it on the PCB.
another thing to consider is like, the team generally does hand soldering for basically everything. So if you're picking out components that are like 0.25 millimeters long, you're gonna have to solder that, so it's good to pick bigger footprints where you can. But yeah, it's kind of like a game of cat and mouse a little bit, because you'll say, oh, I need this value of capacitor, and then you'll go look it up and be like, it's only available in these sizes, can I use a slightly different capacitor that will be a shape that fits on my board better? Or maybe, you know, like I found that 350 ohm resistors don't exist, they're like $30 each, because they're so non-standard, but like 347 ohm capacitor or resistors are like super standard, they're 10 cents each. Super weird, but that's just how it is.
Just make like. Whatever, concessions where you can.
Yeah, yeah. So the last thing we'll have to do here is we want KiCAD to know that this resistor here is different than this resistor here in its net list. Basically what that means is we want to make this exclamation mark or this question mark to a certain number, so that KiCAD tells them apart. So conveniently, if you look at this icon, it says R question mark with an arrow pointing to R42, which is exactly what we want to do. And all you have to do, yeah, actually I went through that pretty quick here. So it's up there at the top. The fill in schematic symbol reference designators. Go ahead and click that. We want to annotate, this is called annotating the schematic. We want to do the entire thing because nothing has annotations. We don't care if we're keeping or resetting existing annotations. This kind of comes into play more if you like delete some components and add some new ones. You might not want to reset them.
Okay, the tool and hit schematic.
Yep, it's also just at the top. Oh, you're zoomed in, so maybe you can't see it. But regardless, just click annotate. You can see if you read through the output, it's like, oh, we called the 1K resistor R5 and the 10K R6. And then when you look on your schematic, each one has a nice number that's associated with it.
All right.
Yeah, I'll put my mouse on it on the screen here.
On Windows, you just get annotation complete.
Oh, really? That's actually a huge pain because you use that output a lot. Or at least I do.
But it didn't tell you what was ending.
Yeah, I just said annotation complete.
Maybe there's like a verbose setting or something. That works for you.
All the detail.
Yeah, 2K.
Is there like a verbose Oh,
Yeah, so like close the window, then go control Z.
what about the annotation messages? Like if you look on the screen, there's all these like settings for what you want to see.
Okay, yeah,
Schematic.
yeah, it did.
Oh, okay. Cool. That is it's a helpful thing. Sometimes you'll go through and you like hit annotate and then it'll like spit out a million lines because it just re-annotated your whole schematic. That's where you want to know, because then you can do Control Z and just annotate the stuff you want. Anyways, so now that that's done, we need to assign our footprints. So they make like a million different, sorry?
Sorry, just as it annotated, is there like a logic that it annotates to, like lowest value?
Yeah.
is what-
That's a good question. Look at the order. Sort symbols by X position, sort symbols by Y, and you can, yeah, kind of do some things to make it a little more smooth.
Okay, thank
Usually it doesn't matter too much, but in some cases it does when you want to do scripting. So you want your annotations to be like in order.
so, yeah.
You'll see why that matters in a bit.
So each resistor, is each resistor labeled uniquely or no value of it's like a photo?
Each resistor is unique. Yeah, so like R1, R2, R3 could all be 200 ohms. Yeah. So this schematic, sure, we know that our resistor is 200 ohms. It looks like a little rectangle, but in reality, there's like a million different kinds of 200 ohm resistors. So you have to say to KiCAD what you want that resistor to look like now. And that's where we run our footprint assignment tool. And so that's up beside the, so go ahead and click that. It might take a second to load the libraries because there's, again, like a million of these things. And we're going to go and pick footprints. And this is where you guys should stop following exactly what I do and just pick wacky looking components so that your PCB looks really weird, because it's more fun that way. So there's all these footprint filters at the top here. So you can filter by symbol. So when you're looking for a resistor, we filter by symbol. So I'll click on R1. You can see that we got a lot of resistors on the side here. It's not perfect. We got some opto devices as well. But basically all of these are a specific shape. And so if I click on just this random one here, we got an 0805 2012 metric. That's a pretty classic footprint right there. You can click on view selected footprint in the footprint viewer. I'm going to go ahead and do that. And this is what it looks like. This is the physical shape of the thing that will be printed on your PCB. And to give a little bit more context of what it actually looks like, they also include a 3D viewer, which I will attempt to use without a mouse. There we go. Okay, so you can see, there we go. So that's a little resistor on your board. So pretty sweet. I like to use the 3D viewer a lot because it's a good sanity check that you're not picking weird components. And sometimes you'll pick a resistor, you'll be like, oh, that looks great. But you know, the right size that I want. And then you open it up and it's like super not standard, like weird footprint. So that 3D viewer is very helpful.
Do you have any general rules of picking ones that are standard?
Yeah, so that's something that you kind of need to just like design a PCB and then go and try and find those components on DigiKey, because when I first designed it, I had no idea. Like, look how many fucking options there are for resistors here. Like, how do you know which one to pick? I started looking at them and I was like, oh, well, this 0805, that's the dimensions in millimeters, I believe. So, and then you can see they also have, oh, actually, that's not even true. The other one here. So 1.2 millimeters by 1.4 millimeters, and it's called a hand solder component. So when we're working with the team, probably want to pick hand solder components because they're going to be a little bit bigger. The pads will be bigger.
Do we actually solder on surface mount resistors and such? We don't just pay to have that done with the PCB?
No, we're free labor.
Some places do it cheap. Oh, the IEEE reminds me, it's a little reflow of it.
Yeah, I would actually like to do some reflow, but on the last rocket, we soldered everything by hand.
Yeah.
And it's honestly not too bad, and unless your PCBs are getting like really complicated and a shitload of components. But
Yeah, 0805 is probably the smallest you want to go for. Unless you're doing more of an advanced design, 603s are solderable. But they get paid.
Yeah.
Smaller.
Yeah.
And solder 0201, it'll never happen.
You gotta have steady hands.
Yeah.
So anyways, basically you click your component and you click on the footprint you want. So I want all my resistors to have the same footprint. So I'm just gonna Control C and then select all of these. Control V, so now they all have the same footprint. Same goes for the capacitors. You scroll through. Yeah, the filter by library is kind of, or filter by component isn't great. Let's go with some wacky through hole capacitors here.
Let's go with 5 pickups, let's go with 5 pickups. Now we'll have someone connected.
The each resistor size.
Good connectors, like stock connectors.
Oh, so it's this.
Yeah, that's what's assigned to it.
I've got it up on here if you don't find it. So yeah, just go through, pick some cool looking stuff. You can also filter by like library and filter by pin count. You can also just search for a certain footprint. It's kind of up to you.
It's possible that
Oh,
It doesn't stop you from doing like a 32-pin footprint on a 4-pin device.
no, it does if you filter by pin count. Which is also, yeah. But if you did want to, you could do it.
Maybe you're purposely only having connections, but you want an HDMI cable, but.
Well, it could be something like you have a bus, right? And you need a 32-pin connector to fit on your bus regardless of how many inputs, so. There's a time and a place, I guess.
I feel like you just put in the schematic. as a
Okay,
connector and then like kept that thing.
Okay, and it's like connector DSP, okay, there you go.
So I've picked all my components and all their footprints.
is it normal to not be able to see the footprint?
That's probably because they're not downloaded. So when you download KiCAD, I think there's like an optional.
There's a couple menus. This is my first time using it where it like it has a pop-up and it says, do you want to use the default or select the path? And
Yeah,
if you have it okay, it'll import all that.
I just spelled this every day. And there's 6 gigabytes. 6 gigabytes. That have a year's worth.
I don't know.
I feel like it's pretty small. Anyways,
Yeah, I got it.
maybe I'm wrong. I know sometimes the 3D components don't get downloaded automatically, but I don't know why. So anyways, did everybody pick footprints for their
Alright,
components?
now it's time to go with the.
You have to press apply, it saves schematic input.
That is correct.
And purpose association?
That's right.
Yeah, now here we go.
Okay, no worries. Yeah,
There's the schematic. Back to basic, and now PCB KiCAD.
it should just be in the. Oh. Boom. Okay. Girl, good.
Should there be some kind of response when I hit the button?
No, it just saves it basically. Okay, so we're all done. Except for one thing, which we're not really gonna cover that much, but if you look at the screen, there's the perform electrical rules check button. Try clicking that and click run ERC. You can see it gives you a few violations. These don't really matter that much. Basically, all it's saying is that like you don't have any power coming to your board because you don't have a power flag attached to your power. It's stupid, it doesn't matter right now, but this electrical rules checker will help you find like if I had a component that wasn't connected to anything, it would say pin 2 on resistor 23 is unconnected, and then you can go and fix it.
How do you connect?
That is the run or
That's
perform
fine.
electrical rules check. Yeah.
It's in spec, and it's under inspect.
You can also set your own custom rules check. So like, I think within that you can set like band footprints, you know, like our company never uses these kinds of footprints. And then if you accidentally assign one, that would find it and be like, don't use this component or don't use this footprint. Anyways, I don't want to drag this out too long, so we're gonna speed run this next part here. We have completed a schematic, so now we can actually lay out the PCB. So click the PCB board editor button. That's the green one there. Actually, don't go back and do that.
Oh.
Yeah, do it from the schematic, or else the two applications won't be linked.
File.
There you go.
Tools, which is the editor.
That's right. Okay, so you're greeted with another schematic looking thing, but this time it's black. What we want to do is basically load in our schematic. So all you have to do is click this button. If you notice, it's got the schematic editor and PCB editor icon combined into one. That's saying, do you want to load everything from the schematic into the PCB thing? Then you just hit update PCB, and you can see
I got error 1. That's fun.
you get a bunch of components that pop in. And just so you guys know, that was this button up here. Apparently it's F8. As a shortcut. So anytime you make any changes to your schematic, like say you change a connector or you add another resistor or something, you have to save it in the schematic and update PCB with changes made to schematic in order to bring those new components in. So now that we have our components, it's kind of the same deal as always. You can hover over a component, you can rotate it, and this is basically how you lay out a PCB. So remember, the location of these things is the actual layout of your PCB. Like, this is what it will look like. So in the schematic, it didn't really matter if your wires were all over the place. Here, you actually want things to look good. And all these little white lines that are running around here, those are your rat's nest, is what it's called. And that tells you what connects to what. And it's kind of helpful because it gives you an idea of where traces on the PCB will have to run. So if you can sort of make your components line up in a nice way, that would be good.
Yeah, I'm just trying to make that DNA. That's some weird.
How are people doing with their layout?
Not good, but later.
Okay.
Okay. That's
Does it matter if the rat's nest overlaps?
No, you'll see why, but you want to like have less overlap if you can. Kind of like if this component is connected to this one, put them beside each other, that sort of thing. But you'll see why it doesn't matter. Doesn't matter a lot, I guess. Is everybody happy with their layout?
No, but that's just, I gotta work on that.
That's okay. Are you just starting your layout, Blaine?
Yeah.
Okay. Okay. Yeah, well, I'm gonna move ahead, but keep laying out your components. We're just gonna make the edge cuts of our board. So if you open up the 3D viewer, which is Alt-3 on the keyboard, you can see we have a nice PCB here. Some nice 3D models. But you'll notice that our PCB is just a rectangle, and that's not very cool. So we're going to do something about that. And the way you can change the shape of your PCB is with your edge cuts. So if you look on the right-hand side of the screen, you can see there's all these layers. If you've ever used Photoshop or Inkscape or something like that, you basically have layers that you can like do certain things on. So on the right side, there is a edge cuts layer, and you want to select that layer. So that's the this guy here, edge cuts. So once that's selected,
Oh, okay, it's gonna be,
once that's selected, you can start using all the drawing tools on the side. So I'm going to make a sick polygon.
it's just route tracks or?
Oh, it makes it.
Oh,
Yeah. See, this is looking like the peak of
graphic polygon?
PCB design. Boom. That's fantastic. Okay. And there's all these other tools too. You can draw squares, rectangles, circles. You can also import curves from a CAD program like SolidWorks. So you can get as crazy as you want, which we might actually have to on the rocket because it's round and it's got posts going everywhere. So we're gonna have to do some weird things with the shapes of PCBs, but that's okay. So now if I open up the 3D viewer, you can see that my PCB is now a lovely polygon. Is that working for everybody? Good. Okay, this part isn't really that important. So if you're like falling behind, just put a rectangle there on edge cuts and call it a day.
What was the draw tool?
The draw tool. Oh, yeah. So select edge cuts
Yeah.
on your layers, and then it's any of these lines.
Okay.
Yeah, anything you want.
Yeah, I just went crazy around.
The next thing we're going to do is switch back to our front copper layer. That's the first entry, the FCU. And this is where we actually start connecting components together. So if you'll recall, PCBs have two sides usually, front copper, back copper. So we'll start wiring on the front side, and if we need to, we'll switch to the back side. So
So we are already done spaces and then we do it.
if you recall in the schematic editor, to lay down a wire was W. It obviously translates that would be X in the PCB editor. So to lay down a wire, you hit X over a pad, and you can see because of the net list, it tells us exactly where this wire needs to connect to. It knows that this connects to that because of the net list. So now you just go around and you hit X on everything and you connect things together.
I was just like, my stuff is not like,
It's all good, man.
yeah.
All good.
On the actual PCBs that we make, we do front, back, how many layers of traces do we do?
Try and do two layers if you can, because it gets more expensive to do more. And to be honest, I doubt anything that you do on the team will require 4 layers unless it's like a really, really small PCB with a lot of stuff on it. But you do a lot with 2 layers. Just put it that way. Some other things to sort of note here, we're just using the default trace size. If you're doing like some really high power stuff, you would want to calculate how thick your trace needs to be to like not catch fire basically. And then you can set the thickness of your trace. It's also good practice to just make the trace as thick as you can get away with, because it's a lower resistance, so kind of get like less losses and that stuff. Things that don't involve microcontrollers, basically. Now, if you have like a MOSFET that's switching like 10 amps, you're going to want to do some serious power calculations. But like I said, you want to go thicker traces where you can. Yeah. If you've got the space for it, you should just do thicker traces, to be honest. But I'm not going to bother with that right now because I just want to get this done.
I got small capacity, I have pretty small capacitor.
Okay, so if you guys will take a look at the projector, you can see I have a dilemma. I want to connect this to right there.
No.
Ignore the fact that I can go around this. I can't, I have to go this way. So we're gonna use the other side of the board. We're gonna jump from the top layer to the bottom layer, go under this trace, and then go back up. And the way you do that is with a via. And so a via is just a hole in the board that's been plated. So you can connect both sides of the copper together. So to do a via, you just press V, you can see a little circle pops up, and then wow, automatically I'm on the back side of the board, and I can go right under that wire. And then I can just press V again, come back up to the top side. So there we go. So we're connected now, no problem.
Say that again, how do you do it again?
Just press V. So when you're drawing a trace, you just press V. It should switch to via tool, and then you can just click and it will place a via.
Okay.
Hey, how's everybody doing?
I'll do this.
Okay. So if you have a look now at the 3D viewer, you can see all my things are connected together.
Oh, you got massive capacitor.
Yeah, we've got some huge ones on here, and then some tiny surface mount resistors. I like that a lot of variety in my PCBs, you know.
That shape.
So ergonomic.
That shape, whatever.
There, can't you tell that fit right in a round rocket band? Okay, so last couple of things I want to go over. If you look at the board, you can see that it's blank everywhere except where a trace is. Basically what that means is you've like taken your copper front plane of your board and you've etched away all the copper, except in the places where those traces are. That's not always desirable because fiberglass are transparent. So it would be nice if we could have some kind of shielding for all those traces. And the way you can do that is by defining fill zones. So if we go, where is the fill? Change the icon. Oh, here we go. Add a filled zone. It's the rectangle looking button here. So I'm going to add a filled zone. And yeah, I want to do front copper and I want the filled zone to be connected to ground. I think this will just work. Yes. So right now I'm defining a filled zone. So everything inside this is going to be filled with ground. That's basically what it means.
Well, like the ground is that plate.
Yeah, pretty much. So now if you look in the 3D viewer, oh, I didn't fill it. Does everybody get what I just did there?
You have to fill zone and then you have to fill.
So the reason I did that is I don't want as much interference on the board. So I'm going to make this entire polygon here just ground. It's just going to be ground copper. But if I open up the 3D viewer, you can see nothing's changed because I haven't filled my fill zones. All you have to do is press B. And you can see now it's full. You can just press B. The reason it doesn't do it is it makes it hard to see what's going on. So you can see it's kind of hard to tell what things are anymore. So you can press Control B to unfill. But I'll fill it up and then I will have a look. And you can see it looks much different now on the PCB editor. So what's going on here is that this trace is still electrically isolated from ground because it's got this little buffer zone around it, but everywhere else here is all ground. And the reason you'd want to do that is it helps reduce interference because ground is kind of like blocking electromagnetic interference, basically. There's other reasons to do it too. So you can use it as a heat sink as well. If you want.
How much?
It's pretty common to use it as like a large heat sink in some cases.
Mhm.
But yeah, that's honestly, that's about it for basic usage of KiCAD. I was going to talk about scripting a little bit.
For.
Yeah, I don't.
720 and-
Yeah, I don't want to get
Wanna
into that.
people home?
Here's the 10-second intro to scripting. Basically, there's a shell built in, and you can do some basic Python to just like interface with KiCAD. So you can manipulate the location of components just using Python, which is super helpful if you want to do like weird layouts of things. I sent some code in the Discord. This is a script that will lay out components radially.
Which you are showing for the.
So you can see.
No, you're gonna think about board except for different like, ABC, whatever.
Sort of, yeah. There's a bit more going on, but
So, no, 8, 6, 7, 11.
nope, those will still be on there.
I was trying to figure out like which ones are you gonna try to go use with that.
Yeah. So any questions about the whole process? Because that's kind of all I wanted to really show. There's like a million other things you can do in KiCAD, but that's like the bare bones to be able to make a PCB.
How do you view 3D work?
Alt 3. You can also, I think in view in the 3D viewer. Did you manage to get the 3D stuff?
Yeah.
Oh, nice. Cool. Oh, there's also ray tracing in the 3D viewer. So you can turn that on and then wait like 30 seconds. So I'm gonna do it. Yeah, RTX is on, boys. Look at that, it's got beautiful shadows and dynamic lighting. So you guys should go and do that and then post a screenshot of your awesome PCB in Discord. Because that's what we did last time. And it was fun.
Where do you go for ray tracing?
It's the little like cube top left, yeah. See how fast your computers are.
Option.
So yeah, once you've rendered it, send a picture of it in the Discord.
Yep.
So everybody can see what they missed out on.
Well, sorry.
Oh, I didn't have my fill zones. Terrible.
Right.
What layer do you do the
Ray trace it again.
The which?
what layer do you do?
The copper, front copper layer.
Back front up?
Just either one.
Oh, both?
No on either side.
Okay. Go here. And you select. Draw. And the button.
Yeah, there you go. And you have to say what you want that fill zone to be connected to. So generally you'll do ground and power.
Okay.
Because the nice thing with that is like, say you have some components over here and they need to be powered. Yeah, we just automatically connect to the fill zone. Rather than you running a wire.
Yeah. And the same.
Yeah. So tons of components like chips will have ground pins on them. They'll just automatically connect. Yeah.
Okay, so
Okay.
selected it. And then, or I've done it.
Yep, that's it.
And then do I click Control V?
It looks like it already built, but you hit B. Oh. Yeah. Control B should on.
Right.
Oh, yeah.
Yeah. See there?
Yeah, gotta get ready to go home soon.
Sweet. All right. Well.
We didn't even play for it.
Oh, yes, sir.
Oh, gotta get
All right,
home,
everybody.
finish the math work by midnight, that's gonna be fun.
Oh, circular piece. Ooh, that's clean. It's clean, Arturo. I like it.
There it goes.
Order that, just get there.
Oh, it's just a boring circle.
Oh,
Yeah.
well, we gotta go put a hole
I
in
used
that.
like 3 LEDs, 3 resistors, and 3 switches, and it's just LED switches. Make you feel more got big metal switches. Felt the other you turn on. Yeah. Only no power supply, that's what, but.
Right, stop this recording.